In this lesson, we're going to expand our look at organic nomenclature, learning how to name compounds from a variety of different functional groups. So the first class of compounds we're going to learn how to name are alkyl halides. An alkyl halide is really just an alkane that has a halogen as a substituent. Now the halogen substituent itself is actually named by taking the halogen name, say fluorine, and dropping the INE and replacing it with an O. So fluorine becomes fluoro, chlorine becomes chloro, etc. Now, in all other ways, halogen groups are treated exactly like alkyl groups, and the process is the same as naming an alkane. The first step is to always find that parent chain. So if we look at this first example, the longest carbon chain is that 2-carbon chain, so this is going to be an ethane derivative. But you can see that we've replaced one of the hydrogens on ethane with a bromine. Well, the substituent name for bromine is bromo, so we simply place that in front of the parent name. So this is bromoethane. We do need to number the carbons of the parent chain, again starting from the end that is closest to the substituent. So in this case, the 1 carbon would be the carbon bonded to the bromine and then the 2 carbon next to it. Again, you'll notice that there's no 1 in the name. I didn't say 1 bromoethane. It's okay to do that, but again, there's no such thing as 2 bromoethane, and since there's no ambiguity, most chemists simply don't place the 1 in the name. But again, remember that halogen groups are treated exactly like alkyl groups. There's no special preferential treatment or anything. So look at this next example. Always go back to the beginning of the process for naming compounds. Find that parent chain. In this case, the longest carbon chain is a 5-carbon chain. And then we would number that chain starting from the end that is closer to a substituent. It doesn't matter what kind of substituent, right? Just a substituent. So in this case, we can get to that fluorine substituent quickly by starting on the top left. We number the carbons sequentially, and we can see that the fluorine is on 2, and we have a methyl group now on 3. From there, we simply place those 2 substituents, each with their locant, listing them alphabetically just like we did with alkyl groups, and then all that before the parent chain name. So in this case, we get 2-fluoro, 3-methyl, pentane. Next, we're going to take a look at ethers. An ether is really an alkane that has an alkoxy substituent. An alkoxy substituent is really like an alkyl substituent, except that it's bonded through an oxygen to the actual parent chain. In fact, alkoxy groups are kind of named that way. You name it as though it were an alkyl group, and then change the ending instead of YL to OXY. So alkyl, like methyl, becomes alkoxy, like methoxy. Another way to think of ethers is an oxygen bonded to 2 alkyl groups. Look at this first example. We've got an oxygen, and on one side of it a propyl group, and on the other side of it an ethyl group. In fact, that's how they used to be named. But we're going to learn the IUPAC, the systematic way of naming these. Again, the first step in any naming is to find the parent chain. You're pretty much guaranteed to have 2 separate carbon chains in an ether. So in this case, the longer carbon chain is that 3-carbon chain on the left. So this is going to be a substituted propane. We would then number the carbons of that chain, starting on an end that is closer to a substituent. And the substituent here is that ethoxy group, right? The ethyl group that also has an oxygen that bonds it back to the parent chain. So we have an ethoxy group bonded to the propane, and that means that the 1 carbon is going to be the carbon that bears that substituent. So we number 1, 2, 3 going right to left. And that means we simply have 1-ethoxy propane. Again, the ethoxy substituent name is placed in front of the parent chain name with its locant. Just like with halogen substituents, alkoxy substituents are treated exactly like alkyl groups. There's no preferential treatment with these. So let's look at this example. Again, find the parent chain. In this case, we can see that the longest carbon chain is a 5-carbon chain. We then number the carbon chain starting from the end that is closer to a substituent. So in this case, we're going to go from left to right. And we can see that our alkoxy group, right, it's really just a methyl group with an extra oxygen that bonds it back to the parent chain. So this is going to be a methoxy group. So here we have 2-methoxy pentane. So the remaining functional groups we're going to look at naming are actually treated quite a bit differently than the alkyl halides and the ethers we just looked at. The first of these is going to be alcohols. An alcohol really is just an alkane that has a hydroxy group. And unlike the other groups that we've seen, the halogens and the alkoxy groups, an alcohol is actually indicated in a name using a suffix, in this case OL. So we drop the E from the alkane name and add OL to say that it is an alcohol. So look at this simple molecule here, right? We can see that the parent chain is going to be a 2-carbon chain. That's always the first step. We number the carbons starting on the end that is closer to that functional group. In this case, the rightmost carbon actually bears the functional group, so that gets the 1, and the other carbon the 2. So it's a 2-carbon chain, it's an ethane derivative, it's an alcohol, So we drop the E, add OL, and we have ethanol. This is the booze molecule. Look at the second example. Again, find the parent chain, and it's a 5-carbon chain. We number the parent chain, starting from the end that is closer to that functionality, in this case going left to right. And that means that we have the OH group, the alcohol, on 2. So a 5-carbon chain is pentane. We have 2-pentanol. Notice that the locant for the actual substituent, the hydroxy group, the ol, notice that that locant is actually placed before the parent name. It's not really placed in front of the whole name, it's just placed in front of the parent name. So 2-pentanol. There is an alternative way to do this. You can also put the 2 directly in front of that suffix, right in front of the ol. So while most chemists would say 2-pentanol, it's actually more technically correct to say pentane 2-ol. But since it's harder to say, most chemists, even now, simply rely on saying 2-pentanol. But either way is technically acceptable. Now, there are a couple of new rules we have to worry about with these suffix modifying groups like alcohols. The first modification to our original rules from alkanes is that the parent chain must contain the carbon that bears that suffix modifying OH. So look at this example. At first glance, you would say, oh, the parent chain is going to be the longest carbon chain. And that looks like 1, 2, 3, 4, 5, a 5-carbon chain. Notice that none of those 5 carbons actually are connected to the OH. So when you have a suffix modifying group, yeah, that's not going to be the case. The longest carbon chain that actually is attached to the OH is the parent chain. And that means that the parent chain here is actually going to be 4 carbons, the 4 carbons going left to right. So yeah, it's actually shorter than the total longest chain. So once we know that the parent chain is this 4-carbon chain, we number the carbons of that chain, again, starting from the end that is closer to the suffix group. And that means we're going to start from the rightmost carbon, giving that a 1, and then 2, 3, 4. And then after that, it's pretty straightforward. We can see that we have an ethyl group attached to carbon 2, and that the OH is attached to carbon 1. We place the substituent name with its locant in front, so that's 2-ethyl, and then 1-butanol, to note that the alcohol is on the 1 carbon of a 4-carbon chain. Another difference with alcohols and other suffix modifying groups compared to our prefix groups like alkyl groups and halogens is that suffix modifying groups have a numbering priority compared to the prefix modifying groups. Look at this example. You can quickly see that it's a 4-carbon chain. So it's going to be a butane, and it's got an alcohol and a chlorine, so it's got a halogen. The new thing now is in numbering that parent chain. You'd probably be tempted to start from the rightmost carbon because that's the end that is closer to a substituent, right? In fact, it has a substituent, the chlorine. If we were to call that rightmost carbon the 1 carbon, that would make the alcohol on the 3 carbon. But alcohols, as suffix modifying groups, have a prioritization in numbering the carbon chain. We have to give it the lowest number possible, but again, we have to start numbering on the ends of the chain. And that means that if we started on the leftmost carbon, that will place the alcohol on 2, and 2 is lower than the 3 we would have gotten by starting the numbering from the far right. So we actually number it from left to right in this case. We can see that the chlorine is now on 4 and the alcohol is on 2. So here we have 4-chloro, 2-butanol. So this is a rule that's pretty easy to overlook. When you have suffix modifying groups like alcohols, you have to give them priority in numbering over all the prefix type groups. Now, don't just start on the carbon. Don't start your numbering on the carbon that bears the OH. Remember, you still have to start your numbering on the ends of the chain. It's just that in this case, we would get to the alcohol more quickly by starting on the left. Even though that puts the chlorine on 4, it gives the alcohol the lower number 2, rather than the 3 we would have gotten by starting our numbering on the right. Amines are another important functional group. An amine is really just an alkane that has an amino substituent, a nitrogen-bearing substituent. And again, this is going to be introduced to the name using a suffix, in this case, amine. We drop the E from the alkane name and simply add the entire word amine. So again, look at this first example. We go back to square one, find the parent chain. In this case, it's a 2-carbon chain, so it's going to be an ethane derivative. And we can see that we have this nitrogen attached to 1 carbon. We numbered the carbons of the parent chain, starting from the end that is closest to that suffix modifying group. So in this case, we would number the chain from right to left to give the amino group the lowest number possible, 1. And then we simply tack on the amine ending to the ethane name. So this is ethanamine. Again, technically 1-ethanamine, but most chemists won't say the 1 because there's no such thing as 2-ethanamine, so it's unnecessary. One of the interesting things that arises with amines, as compared to some of the other groups we looked at, is that you can actually have substituents on the nitrogen. Take a look at this example. Again, find the parent chain. Well, you can see in this case, we actually have two separate carbon chains attached to the nitrogen. We have a 4-carbon chain on the left and a 2-carbon chain on the right. So the longest carbon chain that actually is connected to the nitrogen is the 4-carbon chain. So this is going to be a butane derivative. And we number the carbons accordingly, right? We start on the end that is closer to that suffix modifying group, which in this case happens to be the rightmost carbon because it's attached directly to that carbon. So we can see that we now have a 1-butanamine. But we actually have a new substituent. We have this ethyl group, and it's not attached to the actual parent chain, right? The ethyl group is actually attached to the nitrogen. So the way we indicate that in the name, we give it a new locant. Because it's not actually attached to carbon 1 or 2 or 3, it's actually attached to the nitrogen. The locant we use is a capitalized, italicized N, standing for nitrogen. So we place that locant in front of the name, ethyl, and so we have N-ethyl 1-butanamine. That N, again, is a locant. It's acting like a number. It's telling you where that ethyl group is on the molecule. It's not on the parent chain. It's actually attached to the nitrogen. Look at this last example. Again, always go back to the beginning of the process, find that parent chain. The parent chain is going to be the longest carbon chain that actually is connected to the nitrogen. So in this case, it's a 6-carbon chain. From there, we number the carbons of the parent chain so as to give the amino group the lowest number possible. Remember, the amine is a suffix modifying group and it has preference over the other groups. In this case, we have a halogen, but that's a prefix group. So that means we have to number the carbons here from left to right. That's going to put the nitrogen on 3. If we had started from the right, that would actually put the nitrogen on 4. It would give a lower value for the bromine, but that's subordinate to the nitrogen because the nitrogen is a suffix group. So again, we are going to number this left to right, and we can see that the amine is on the 3 and that the bromine is on 5. In this case, we have two substituents on the nitrogen, and they happen to be methyl groups. And we already know how to treat multiples of the same substituent, right? In this case, since we have two methyls, we're going to say dimethyl. Now remember, every substituent needs a locant, even if it's in the same location. And in this case, those methyl groups are on nitrogen. And that means we use that N locant, but in this case, we need it twice. So we list this out as N-N-dimethyl, separating the N's with a comma because they are locants. And of course, we have to alphabetize all the substituents. So in this case, it's going to be 5-bromo, N-N-dimethyl, and then 3-hexanamine.